So in this class, we will discuss another one or two problems on application of Dirac principle. In the earlier videos, I had discussed about two problems. Now here it is a connected body problem. Connected body means there are two weights here. One weight is 200 Newton block, another block of weight 800 Newton. They are connected by a string. So you know that in the string tension force always will develop. So tension force is denoted by the force acting away from the block. So like this, and if you take tension on this block, it will be like this. So totally this string will be in equilibrium. So tension force always acts away from the object. Now the connected body system is acted upon by an external force 400 Newton like this. So since this 400 Newton is acting in this direction, naturally the direction of motion of the system will be towards right in the direction of this 400 Newton. He has given that the surface, horizontal plane on which the blocks are lying, it is a rough surface. The coefficient of friction of that horizontal plane contact surface is 0.3 here given. The question here is determine the acceleration of the system, that is A, with which it moves. Acceleration will be, since the system is moving in this direction, acceleration will also be in this direction, and also the tension in this field. So T value. So A and T values we have to find out. So just as we discussed in the last previous problems, we had to write down the free body diagram of both the blocks separately. So first I will write free body diagram of this 200 Newton block. So 200 Newton is the weight of the block which acts vertically downwards like this, and a tension force will be there in the string which is connected to this 200 Newton block like this. Then since it is moving in this direction, frictional force and inertia force also will be there. Both those forces will be acting in the opposite direction of motion. So I will write the inertia force in the opposite direction of motion like this, Fy, which is m into A, which is W by G into A. So W here is weight of the block, which is 200 divided by 9.81 meter per second square is the magnitude of gravity into E. A is not known here. And also the friction force acts at the contact surface in the opposite direction. So frictional force I will take it as F, which is nothing but mu times N, when N is the normal direction. So mu is given as 0.3, therefore F is 0.3 times N. So this is the free body diagram of the block, that is 200 Newton block. Now here I have to apply the dynamic equilibrium equation as I already told, the direction of motion of the block. So this is the direction of motion of the block, x direction and y direction normal to that. So now if I write the equilibrium equation in the y direction first, that means sigma Fy is equal to 0, treating upward positive, downward negative. If you see the system, here 200 Newton is acting downwards, weight of the block, N acts upwards, N is the normal reaction. So what I can write here is minus 200 plus N. This N is Newtons, this N is normal reaction. So is equal to 0, that's all. There are no other forces acting in the y direction. So N is equal to 200 Newtons. So normal reaction is equal to 200 Newtons by using the first equilibrium equation in y direction. Next, let us write the dynamic equilibrium equation in x direction, that is along the direction of motion. So in other words, it is nothing but sigma F is 0. So that is a dynamic equilibrium equation, considering the inertia force also, Fy also. Now if you write this, I will take the sign convention, forces acting in the direction of motion, that is towards right as positive, then towards left negative. So if I take the sign convention, if you observe the diagram, T is positive, F is negative, Fy is also negative. So three forces are there. So T is positive, so plus T minus F minus Fy is equal to 0. So this is the equation. Now substitute now for f as 0.3 times n. So t minus 0.3 times n minus fy is 200 by 9.81 a. So this is equal to 0. So from this you can get an equation. N value, of course, you know we have got n value as 200 newtons. Thus you can substitute t minus 0.3 into 200 minus 200 divided by 9.81, that we can simplify. So it is 200 divided by 9.81, which is 20.39 or 387. 20.387 times A is equal to 0. Or in other words, you can write it as T minus 20.387 times A is equal to 0.3 into 200, that is 60. So this is the first equation we get by writing the dynamic equilibrium equation for the block 200 Newton. Now we need one more equation to solve because there are two unknowns here, P and A, that we can obtain by writing the free body diagram of 800 Newton block. Second block, FBD of 800 Newton block. So for this, once again, if I write the free body diagram, so weight of the block acts vertically downwards, 800 Newton. Then there is a force of 400 Newton acting on this. And if you take the tension and the strain, tension acts like this towards left for this 800 Newton block. So T will be acting like this. And you have the inertial force and frictional force as usual. This is the direction of motion. Inertial force acts in the opposite direction. Fy, which is m into a, that is W by G into a. W is weight of this block, that is 800. 800 by 9.81 times a. This is the inertial force. And frictional force acts at the contact surface here, once again in the opposite direction. So F is equal to mu times N. So here N is this normal reaction. Here also mu is 0.3 he has given, same horizontal plane. So it becomes F equals 0.3 times N. So this is the free body diagram of 800 Newton block. So I am going to repeat the same procedure. I will apply these two equations for this block. The first one, first equation, I will take sigma Fy is equal to 0. Once again here x-axis along the direction of motion, y-axis perpendicular to it. So sigma Fy 0, upward positive, downward negative. This is the sign convention. So see this diagram. So you will be having n minus 800. So this n is normal reaction. This n is newtons. Be careful. So n minus 800 is equal to 0. N is equal to 800 newtons. So directly you will get the value of normal reaction. Now the second equation is the dynamic equilibrium equation. Along the direction of motion, or it can be taken as sigma Fx is equal to 0 because x direction is the direction of motion. So when you are using this equation, force is acting towards right positive, left negative. This is the sign convention. Now we will write the equation now using this same diagram. T is acting towards left, so minus T. F is acting towards left, that is minus 0.3 times N. F is minus 0.3 times N. 400 Newton is acting towards right, therefore plus 400. Inertial force is also acting towards left, it is minus 800 by 9.85 times V equal to 0. So this is the equation we get. Now here, let us substitute for n as 800 now. So this n and this n, they are different. Please note that because the weight is different, n value also will be different. So minus T minus 0.3 into 800 plus 400 minus 800 by 9.81. If you simplify that, you will be getting 81.55. 81.55 A is equal to 0. Now let me write the equation like this. So minus T minus 81.55 A is equal to, I bring this to that side, it becomes minus 400 plus 0.3 into 800 is 240. So it becomes minus 160. Or if you remove minus sign from, it becomes P plus 81.55A is equal to 160. So this is the second equation we are going to get for the second block, that is for the 800 Newton block. Now you have two equations, two unknowns. So you can easily solve very simple equations, simultaneous equations 1 and 2. So what I will do here is I will just write 2 minus 1. Subtracting equation 1 from equation 2, LHS minus LHS is equal to RHS minus RHS. So if you subtract this LHS, T and T will get cancelled. So you will be getting 81.55A plus minus into minus becomes plus 20.387 times A is equal to 160 minus 60. Now if you simplify this, 81.55 plus 20.387 is equal to 101.937. 937 times A is equal to 100. 160 minus 60 is 100. Therefore, A will be 100 divided by 101.937, which is 0.981. 0.981 meter per second square. So this is the acceleration with which the system moves, or both the blocks move. Once you get the value of A, substitute the value of A in one of the equations. You get substitute for A in one of the equations, either 1 or 2. You get the value of tension in the string T. So if I substitute in equation 1, you can write T as T is equal to 60 plus 20.387 times A, that is 60 plus 20.387 times 0.981. So if you simplify this, so you will be getting the value final answer, so which is 79.999, that is 80 newtons. So 80 newtons is the tension in the spring. So this is how we can solve the problem using DRMS principle. So whenever a body is in dynamic equilibrium, DRMS principle can be applied to find the acceleration, or in the case of connected bodies, you can find the tension in the string or the connection, whatever is there. So by just writing the free body diagram of the block separately and applying the dynamic equilibrium equation, which considers the inertia force as well as the friction force.